Hello all. So we're going to do two talks, 15 minutes each. I will start with how Ovn can provide networking to Docker and Kubernetes, and then Dan will take it up a notch and talk about how they use vSwitch for OpenShift, which is a platform as a service. So I won't get into too much detail. Nope. Okay. All right. So I won't go into too much details about Ovn's architecture itself because we had a talk on that yesterday, and only restrict to containers here. So a quick refresher. Ovn has a few logical abstractions. You can create a logical switch. You can attach a VM or a container as a logical port to that logical switch. You can start applying policies. So you can add firewall policies on that logical port, and then eventually you can connect all those logical switches together with a logical router. So if you use Ovn as your networking for your data center, your physical space is going to look something like this. On the rightmost side, you have a couple of hypervisors with vSwitch installed. In each of those hypervisors, you would have a few VMs. Some of them will have containers, some of them will not. You would also have some physical switches which would connect to the Ovn's logical space via a VTAP top of the rack switch. And eventually for external connectivity, you will need an L3 gateway. So when we first looked at Docker integration with Ovn, we spoke to a few container users to figure out what is it that we needed to do. So we had a few design goals in mind. The first design goal was that we wanted each container to be IP addressable. So when I say IP addressable, I mean there should not be any NAT involved. So you could have your VMs, your physical machines, or even any external entity. They should be able to speak to your container purely using container's IP address. Our second design goal was that we wanted to treat each container interface as a logical port in Ovn, which means that all the policies that you can apply to a logical port, you could apply to a container too. For example, you could apply a distributed firewall. Our third design goal was that we wanted to make sure that if a container application breaks out, then it should not affect any other tenants. And finally, we also wanted to make sure that the design should be such that we should be able to easily integrate with Docker, Kubernetes, and any other container orchestrators. So eventually we ended up with a design like this, wherein you will spawn your containers inside VMs. You will have an untrusted vSwitch in each of those VMs, and finally a trusted vSwitch in the hypervisor. So the containers cannot modify the vSwitch running in the hypervisor, which means that even if the container applications break out, your other tenants are not going to get compromised. And if you apply your firewall policies in hypervisor, then the container applications really don't have control over what are the firewall policies that you want to apply. So 2 weeks ago, Docker released Docker 1.9, and Docker 1.9 comes with some networking constructs. So you can create something called as a Docker network, and you can then attach your containers to that Docker network. So in this slide, I have two VMs running around 5 containers. So with Docker network, you can separate them out into different logical spaces. So I don't know how many of you are familiar with the Docker networking constructs, but if you create a Docker network, in Ovn we create a logical switch. And when you attach a container to that Docker network, we just create a logical port in Ovn. And in this case, if you want external connectivity, you would attach a logical router to a Docker network. I mentioned some time back that one of our design goals is that you will have some applications running in your VMs and some applications in containers, and we want Ovn to be able to do that seamless connection between VMs and containers and physical machines. So in this case, you will have a Docker network, and which would be a logical switch in Ovn, and then you would have other logical networks wherein your VMs and physical machines would reside, and you would eventually connect them using an Ovn router, and you would have this seamless connectivity wherein VMs, physical machines, and containers can speak to each other via pure IP addresses. One other thing that I mentioned is that Ovn already comes with distributed firewall. With containers, we provide the same richness. You can create your container anywhere you would like. It could be on any VM, which is on any hypervisor. Ovn would simply make sure that your firewall rule will follow your container. If you destroy your container and move it somewhere else, the firewall rule will automatically follow it. So yesterday there was talk about OpenStack integration with Docker. OpenStack integration with Ovn. So with Docker, we automatically get that because Docker has integration with Ovn, and Ovn has integration with OpenStack. And the commands look, very simple. So the first command is how you create a Docker network. So you have to specify that the driver is Open vSwitch, you give it a subnet, and you give it a name. And then the second command actually attaches that network to your container. So it's this standard Docker commands. There is nothing additional being done here. So how does Ovn's OpenStack integration look like? So right at the center, you have a tenant. And the tenant's goal is he wants a bunch of VMs where he wants to create containers. So he calls OpenStack Nova and says, give me a few VMs. He gets those VMs, and then he installs Docker in all those VMs. And then he just uses Docker API calls, asking Docker to create a network. On each of the VM, we have a Ovn-specific plugin that makes a call to OpenStack Neutron. So whenever you create a Docker network, we create a network in Neutron, which creates a logical switch in Ovn. And similarly, whenever you connect your container to a Docker network, we automatically create a logical port. So this provides multi-tenancy. So you could have multiple tenants using OpenStack and running containers in the VMs. We could also use Ovn without OpenStack, and you could use Docker. So this would be a pure overlay solution. It takes like a minute to come up with a setup like this. So if you read install.docker.md in the OpenVSwitch repository, the instructions are there. Should hardly take a minute to come up with a setup wherein you do the integration. So I will do a quick demo wherein we show Docker's integration with Ovn. So I have two VMs. Both are running on OpenStack, and Ovn is providing the underlay networking. So as a tenant, I can look at all the Neutron networks that have been created by me. So what I'm going to do is that I'm going to create a Docker network. OK, first we'll see that there is no Docker network created, and I'm going to create a Docker network. So this gives me a Docker UUID, and I can see that this exists in Neutron. I can also do a Docker run, which runs your container. And then if I inspect that container, I get an endpoint UUID, which is a Neutron port. So I could just do a Neutron port show on that, and all the information regarding that endpoint exists. So you would have your subnet, MAC address, IP address, etc. So on a different host, I'm going to run another container on the same Docker network. So now I should be able to simply ping those two together. Oops. OK, all right. So this is not an overlay network. So packets go all the way down to the hypervisor. Ovn figures out if it needs to apply any firewall policies. Then it goes to any other hypervisor where your destination Docker container resides, and then it goes back to the VM. So you don't really have an overlay on top of overlay here. So this is a quick demo on Docker. So it is sort of nice to just spawn individual Docker containers, but when you are deploying your containers in scale, you really need a container orchestration system. Kubernetes is a very powerful, complex, but very powerful container orchestration system. And I will give a brief introduction on what Kubernetes is and what are its feature sets. The basic building block of Kubernetes is called a pod. So pod is a group of containers wherein you can have multiple applications running, but they share the same network interface. So you could sort of think a pod to be a VM, because in a VM too you have multiple applications running, and they share a network interface. And a host can have multiple pods. One of the Kubernetes networking requirement is that all the pods should be able to speak to all the other pods in any VM in your cluster. And it should also be able to speak to Kubernetes central daemons. And another Kubernetes thing is that they say pods are fungible. So you can create and destroy pods. They can get recreated on any different VM, and they could have any different IP address. So when your IP address changes so fast, how do you make sure that you can actually access that application? So for that, Kubernetes has something called as a service. A service is a virtual IP address, and it backs a bunch of pods. So you could have 100 web servers with completely different IP addresses, but at the end of the day, they can be accessed with either a DNS name or a virtual IP address. Kubernetes also has something called a replication controller. You can decide how many pods you want at any given time. You could say, I want 100 web servers, and it will make sure that you will always have 100 web servers. Some of your VMs, if it gets destroyed, they will just create new pods in a different VM. So this is how Ovn's integration with Kubernetes looks like. So in case of Kubernetes, we cache the logical port information so that you don't have to recreate them every time pods are created and destroyed. So in effect, on the logical space, you have different pods connected together via a router. So I'll do a quick demo. So I have a 3-node Kubernetes cluster. It's a 2-node cluster, and one is master. And I don't have any pods right now. I'm going to go ahead and create 2 web servers. And Kubernetes will decide where to spawn those web servers. So you could see that with Docker, you can look at all the web servers that are being created. So for connectivity, I'm going to create a client. So now I actually have 3 pods, 1 client and 2 web servers. So I can look at the web server's IP address. So I have one is 1.6 and one is 2.6. So now my client should be able to talk to both of them. So now this is all in different machines. It's just a sort of a manager wherein I can look at them from a single place. So as I mentioned, pods can be created and destroyed, so you need a service really. So I'm going to create a service which gives me a virtual IP address. So I have something called as Apache frontend, which has a virtual IP address, and my client should be able to access the pods just using that. Okay. So there is a load balancer, and it will just balance the traffic to your backend web servers. So that's pretty much what I have. I mean, we still do not have a version 1 product. We still need some work. One is that Ovn needs an L3 gateway for north-south traffic. And right now I am using Kubernetes load balancers, and I would really like to use Ovn's own load balancers because we can do better policy management there. We also need an external load balancer support for north-south traffic, which is more feature-rich, which includes L7 services. But I think we should be able to get that in a couple of months, or maybe 3 months. Dan will continue. Great, thanks.
All right, sorry about that. So I'm Dan Williams, and I'm from the networking services team at Red Hat. And after that great introduction to Kubernetes by Guru over here, I'm going to talk a little bit more about Kubernetes networking and what we're doing with Open vSwitch and the OpenShift platform as a service project. So we're going to take another quick look at the components of Kubernetes. We obviously have user interfaces because without those, nobody would actually be able to use the projects and products that we build. And then, of course, the master, which Guru also talked about, and the nodes, which are the real workhorses of the Kubernetes cluster because they actually spawn the pods and do the real work. So how does this relate to networking? Well, it turns out that we actually only have one networking integration point right now in Kubernetes, and that's on the Kubernetes node. And that only happens when pods are set up and torn down. This is obviously a little bit limiting. So how can we improve on that? And that's one of the things we're working at on the networking team in Red Hat. First off, we need to improve the existing network plugin architecture by adding a couple more integration points where all of the stakeholders for networking in Kubernetes can actually use. Second, we need to make sure that we add a little bit of basic multi-tenancy support to Kubernetes so that it understands all of the different network objects that you might create and which networks map to which pods. We also need to make sure that there's a good security policy for that because you don't just want pods to be randomly able to access certain networks. You need to make sure that they are unable to access networks that the administrator does not want them to access. And we need to make sure that the UI understands all of these concepts so that users can actually use them. Users can inspect their containers and their pods and figure out which networks those pods are assigned to and also change details of the networking in Kubernetes. So if you remember this slide from about a minute ago, this is what it looks like currently again. And this is what we'd actually like to make it look like. We need a bunch of different integration points, first in the UI, whether that's a web client UI like Cockpit, or the OpenShift web UI, or whether it's a command line interface like kubectl or OpenShift CLI. Kubernetes master, because it needs to know about events when users add networks, when they change the networks. And we also need a couple of hooks on the nodes. The existing one for pod setup teardown needs to be enhanced a little bit. And we also need a kind of global hook on the node so that the node itself is aware of when other nodes are added to the cluster, when other pods are born on various other nodes in the cluster or services, etc. So to briefly go through some of these, the current integration point in Kubernetes is based, there's two of them actually. The first one is an exec plugin. And that is kind of like a homegrown Kubernetes API that all the networking providers could currently use. It's fairly limited. And we also added a CNI-based, which is Container Network Interface-based API that basically does exactly the same thing as the exec plugin. However, upstream Kubernetes only wants one networking plugin. So eventually they want to get rid of their homegrown exec plugin and kind of go with the flow and use one of the two existing container network specifications. Currently, that's the CNI. Of course, these are currently limited at this point, so we need to extend them by adding those hooks at multiple places in the stack, the UI, the master, the nodes. And we need to make sure that all of the needs of the stakeholders in this discussion are met. That's like OpenShift or Calico or Weave or Ovn, etc. Right now, Kubernetes is basically oblivious to networking. Like I said, there's only one integration point. We need to add awareness of networks through a couple other places in the stack. We need to make sure that pods can use multiple networks. So for example, if you have one normal network and a storage network, or you want to have them use two networks, we need to make sure it's flexible enough to do that when we're adding these networking hooks and networking objects. We also need to make sure that multiple IP addressing schemes are supported through the networks and through the objects we add to Kubernetes. And we need to make sure that all these schemes are compatible with services and proxies that Kubernetes provides or the networking provider may want to enhance. The security policy, obviously, we need to make sure that pods can attach to various networks, but that they shouldn't attach to networks that they're not allowed to. We can't just necessarily allow the pod to ask for or to say that it should connect to a specific network because that's security through obscurity. If you know the name or the resource ID of the network, then the pod could attach to it when it's not supposed to. So we need to make sure that we have admission control that's flexible enough to describe how pods map to networks, but also make sure that's secure. And this is an area that's under very active discussion right now and is not quite as far along as the multi-networking support. So that brings us to OpenShift. What exactly is OpenShift? Well, OpenShift is a platform as a service project that basically wraps Kubernetes and provides a lot of things that Kubernetes doesn't yet provide. Some of those things are the concept of a complete application. These days, applications are made up of a number of different pods or a number of different services. You might have a database, a web server, some other compute stuff. Those all need to interact together and ideally be started together and live together. And so OpenShift adds the concept of a complete application to kind of manage all those components in unison. Also, another important part for DevOps type people in application lifecycle is source to image building. So you basically, with OpenShift, you can give OpenShift a repository of source code, and it will actually build that source code through you, and then also take you all the way through deploying that image to various nodes in the cluster, and through the complete application lifecycle of development, continuous integration, staging, and production, because of course we don't just build stuff and roll it out right away. OpenShift also focuses on the user experience. So there's an OpenShift web console that provides a good, friendly interface for all of these sorts of things. And then one of my focuses, obviously, on the networking team is I'm working on the out-of-the-box Open vSwitch-based multi-tenant isolated networking that OpenShift currently provides. We're going to, of course, get into flexible access control for those networks as well. OpenShift provides slightly better and more flexible access control than Kubernetes does alone. And OpenShift also does secure cluster communication by default, which Kubernetes is currently just starting to do. So let's take a little bit of a deeper dive into how we use Open vSwitch in the OpenShift project to provide networking for Kubernetes and pods. This looks a lot like the Kubernetes diagram that I showed earlier. There's a master, and that kind of runs the OpenShift master process, and then there's also the node and some of the interfaces. Here we show the IP addressing a little bit of what we've got and some of the details of the interfaces. We also heavily use the OVS bridge for our isolation and multi-tenancy aspects, and all of that is enforced through flow rules. So let's take an even further look into some of those. With OpenShift, the tenant networks are mapped to OpenShift projects, and OpenShift projects are essentially Kubernetes network namespaces. So it's pretty easy to create a new tenant network with OpenShift. You just create a new project for, Pepsi, Coke, or tenant A, whatever. Create a pod in that project, and then you can create another project, which is another completely separate isolated tenant network, and create other pods in that one. And once you've done this, and the pods are in different projects, they cannot talk to each other until you modify the networking configuration later with the user interfaces like command line tools. The tenant networks can be joined, they can be split, they can be isolated from each other. They can also be made administrator networks, which basically means that they can access all pods and all pods can access them. That's used for some aspects of services. On the node side, this is where most of the magic actually happens. The node has to listen for a number of events from the cluster so that it can change the flow rules in the OVS bridge. For a number of things, service changes, node changes, we need to know when new nodes come up so that we can add new flows for the VXLAN tunnel. It also provides a CNI plugin for Kubernetes that actually handles pod setup and teardown. When a new pod is born, we need to add the flow rules to the Open vSwitch bridge to enforce the isolation. And then, of course, updating that pod when network configuration changes. Currently, our IP address management is handled by Docker. We just kind of let that happen the way it was before. We create a bridge for Docker and tell Docker to use that bridge. Then Docker creates the container, does the IP address allocation for it. And then we actually remove that container's network interfaces from the Docker bridge and add them into the OVS one. Isolation is currently enforced through VXLAN tunnels between the different nodes. So there's some VNI tagging that goes on for traffic and then gets shoved into the VXLAN tunnel to go across to another node where we use that tag for the multi-tenant and isolation features. And of course, we have some external access for the pods so they can actually access resources outside the cluster. This is a much closer look at our architecture and how we've sort of put it together. The pods are connected to the OVS switch with a V interface, and every time a new pod comes up, we the vEth interface is created, and then of course attach the OVS bridge, and we update the flow rules for the isolation for that particular pod. VXLAN to the other nodes, and then of course the tunnel, the ton 0 for that's natted to the outside world. And then, of course, that Docker bridge that we have for the IP address management, but also that Docker bridge allows you to run containers with Docker outside of the OpenShift cluster that can still communicate through the OVS bridge. Of course, those are unisolated. So this is maybe one of the more interesting parts for some of you. This is kind of a simplified description of the OVS flows that we have in the bridge on an OpenShift node. Traffic enters kind of at the top of the flow table, and then of course gets dispatched to the other places. Some of the more interesting parts I've italicized for you, and those are the parts that actually deal with the multi-tenancy and the isolation between the nodes. We take the VXLAN ID if traffic is coming in from the VXLAN tunnel, and we put that into, we kind of cache that for later. And then when the traffic would get dispatched to the pods, we make sure that that VNI matches that pod's VNI, and if they do not match, then the traffic is not passed to the pod. Of course, when traffic comes out of the pod, we also tag it because we know exactly which tenant network that pod is on. And that VNI or that tag gets passed into the VXLAN tunnel as well when it's going out to other nodes. There's some rules for service isolation in here to make sure that services can contact pods no matter which tenant network they're on if they're allowed to. And then also we have rules for cluster egress and for external networks. So this is fairly simple, and this is basically the out-of-the-box networking solution that we've developed for OpenShift. And there are some things we want to improve on, and some of those things are that we want to move a lot of this networking stuff out of the OpenShift project itself and move that into other projects like Kubernetes, which is why we spent the first half of my talk discussing Kubernetes multi-networking. We need to add all this support to Kubernetes so that OpenShift, as well as other container networking providers, can use the facilities in Kubernetes. We want to spin that out to Kubernetes. We also want to spin some pieces out to Flannel and develop more community around this, the OpenShift networking solution. We also need to make sure that we keep improving VXLAN performance both in the kernel and in Open vSwitch, because right now, unless you have a VXLAN offload capable network card, the performance is pretty horrendous. So we need to make sure that the ecosystem around VXLAN or Geneva or other tunnels like that continues to move forward and continues to be more performant. We also want to use OVS internal ports instead of the vEth interfaces, but that requires, as I understand it, a couple of changes to OVS to make sure that those OVS internal ports work correctly across network namespaces with respect to accounting and other properties. And of course, if you were here yesterday, you heard about OVS contract and OVS NAT. We'd like to investigate using those in OpenShift so that we can sort of move away from some of the IP table stuff and become a little bit more flexible with our OVS rules and how we isolate and firewall traffic with our pods. And we also want to improve on the IP address management system. Instead of using Docker for that, we might want to use the upstream CNI IP address stuff instead of having this kind of weird Docker bridge off to the end. So that's kind of an overview of what we're doing and how we're using Open vSwitch with the OpenShift project. And that's it. If you guys have any questions for me or Guru, feel free.
All right, let's thank our speakers. And we're running slightly behind, but we do have time for one question.
Guru, in your talk, you mentioned containers running in VMs. How might one support containers running on bare metal with Ovn?
Right. So right now we support VMs with Ovn, right? So wherein VMs are running on bare metal. So your containers will just run like that. So there's absolutely no difference.
Okay, I thought you had a requirement to have maybe a second layer of Ovn on the host.
Oh no, there's
Okay.
absolutely nothing running in the host.
Okay.
We only run containers in the inside VMs because that's what say Amazon or GCP does.
Right.
Because the security model is just better when they're running inside VMs. But if you want to run it on bare metal, Ovn is completely fine.
Okay. Oh, thank you.